Section 4.7 is talking about solving radical inequalities. And solving radical inequalities is very similar to solving equations with radicals on it, except for the inequality sign. And there is going to be one catch that is very similar to when we were solving inequalities of absolute values where we had to do two cases. We're going to have to do two cases in this one. This one will make sense to you as to why we do two cases. But first of all, we're going to solve it like normal, just like we did when we had absolute values. So I'm going to square both sides. And I'm left over with 5x plus 4 is less than or equal to 64. And we'll subtract 4 to solve for x. So 5x is less than or equal to 60. X is less than or equal to 12 after I divide by 5. The one catch that we have to do is since we have a square root, or if we would have any even powered root, so the 4th root, the 6th root, the 8th root, anything like that, inside of this radical cannot be negative. If it's negative, you get an error. You can't have the square root of a negative. You can't figure out what two numbers multiply by themselves to get a negative number. It's not possible. All right, so inside of this square root cannot be negative. So our second case is saying that we have to say inside of that radical, so 5x plus 4 has to be greater than or equal to 0. It can be 0. We can take the square root of 0. Square root of 0 is just 0. So inside this radical has to be 0 or bigger, and so that's exactly what we wrote here. And then we just solve to set our restriction. So subtract 4, 5x is greater than or equal to negative 4, divide by 5, x is greater than or equal to negative 4/5. All right, so we go ahead and write our inequality. Negative 4/5 is less than or equal to x, which is less than or equal to 12. So our values are in between these values here. So it is saying that our x value should be in between here, but we need to check ourselves just like in the other ones in case we have a solution that doesn't work. So we better pick a value inside here and see what works. 0 would be a value inside here. So if I plug in 0 for x, I'll have the square root of 4. Is that less than or equal to 8 is the question. Square root of 4 is 2. That is absolutely less than or equal to 8. That holds true. So this here is our solution. I have one more problem for you. That is the square root of 6x minus 5 is greater than 4. So again, we're going to do two cases. Let's first of all work out it just like it's normal. So we're going to square both sides. So I'll get 5x, whoops, 6x, my bad. 6x minus 5 has to be greater than 16. Add 5, 6x is greater than 21. Divide by 6, x is greater than 7/6, or 21/6. Or if we reduce that, it would take a 3 out of them, we'd get x has to be greater than 7/2. And again, we also have the stipulation that this cannot be negative. So we have to do our second case where we say 6x minus 5 is greater than or equal to 0. So it has to be bigger than 0 inside of there. So if we add 5 over, we get 6x is greater than or equal to 5. Divide by 6, x has to be greater than or equal to 5/6. All right, well, if you look at what we have going on here, it's saying that x has to be greater than or equal to 5/6, and it has to be greater than 7/2. Well, what we have here is we don't have an in-between zone like we did in that earlier example. And we have, this is our bigger number. X is going to have to be greater than 7/2. And in fact, we can check that, pick something that's just bigger than 5/6, like 1. So if we plug 1 into our equation, we get 6 minus 5. The square root of 6 minus 5 has to be greater than 4. Okay, so 6 minus 5 is 1, so the square root of 1 has to be greater than 4. Square root of 1 is 1, and that is not greater than 4. So therefore, that case doesn't work. It doesn't work until we get to here. So our answer, that was part of why we check our work and check what we do. So we make sure we get the right area into where our solutions will work. So hope this helps. We'll see you in class.